let's do our last example. And this will be talking about warranties. So we've talked about casino games, playing games, lottery tickets. Then we talked about insurance companies, and now about warranties, because this has expected value as well. So Best Buy sells an extended warranty for TVs that cost $75. On average, the cost for Best Buy to repair a TV is $275, and approximately 4% of all TVs will need repair. We want to construct a probability distribution and calculate the expected value to Best Buy for each extended warranty they sell. So we're looking for how much Best Buy will make off of this warranty. So I'm going to create my distribution model probability model or distribution. I'm going to call it an event. You can call it an outcome. And then the value. And then the probability. Okay. So you either don't repair the TV, right? It's great within that warranty, or the TV will need to be repaired. Well, for Best Buy, because that's what we're talking about. Oops. Forgive me. Best Buy. There you go. So your value for don't repair is they're going to earn $75. So it's just going to be like that insurance policy, right? They just get that. Now, if they do have to repair it, well, Best Buy did charge us $75, but now they're out $275. So it will cost Best Buy negative $200. The probability of having to repair it, they told us, is 4%, so that's 0.04. And then, well, we know then, because this has to add up to 1, this has to be 0.96. So to find the expected value, it's how much it costs to, if they don't repair it, and the probability times the probability, plus negative, or you could just put minus, $200 times 0.04. And what do we get? Let me do it in my calculator. 75 times 0.96 minus 200 times 0.04. $64. So Best Buy can expect to earn, or a profit of, $64 per warranty sold. That is pretty great. So that's what I was saying, like, this made me kind of rethink buying warranties. The last little piece, so that concludes the notes, but when I was looking at my open math homework, just to be clear, there are some things that they ask you that's kind of tugging on some old information, maybe from a previous math class. One thing is, so let me just draw a line here. Let me just give this a different color. So on mom, they might give you a probability distribution or model that looks like this, where they just say X and P of X. Well, what that's saying is this is the outcome or event, however you want to look at it, and this is your probability. So it's tagging on to the previous section. And they might say, okay, well, 0 times it happens once, it happens twice. I'm making all this up. And the probability is 50%. For 1, it's like 30%. And then for 2, it would have to be 20% to get to the 1. So just realize that's how you're reading it. It's like, okay, for like 0 times it happens, it would be 50%. For 1 time it happens, it'd be 30%. Now what they might say is, okay, now I want you to find when the probability of X equals 1. Well, that would just be the 0.5. Now they might say, find the probability when X is less than or equal to 1. And so that's what I mean by a previous class, because we haven't really talked about inequalities in here, but they're throwing it at you. And so what you're going to do here is you look, because it says less than or equal to, so it includes 1, you're going to just add all the probabilities from 1 and below. Okay, so that's saying, what is the probability that it will happen 1 or 0 times? And so you're just adding up your probabilities. So again, tagging on a previous section and just really honing in on, can you read a distribution model? All right, good luck with your homework and reach out if you have any questions at all.